Hello everyone. Today's lesson is called as solution of inequalities. Okay, this is the introduction. Let's move to the next slide. This is the introduction. So at the beginning, we should need to know what are the inequalities. So as per the basic explanation, we can say inequalities is an expression which implies below mentioned notations. So if you take the first one, is written as a greater than b. So this notation is denoted as greater than b. So for example, for this particular inequity expression, we can say we know that by greater than 2. Okay, let's move to the second one. In that case, it's given as a expression b. This expression is mentioned as smaller than. Okay, as for the example, we can take 5 is smaller than 10. It's the one example for this particular inequality expression. So other example we can take just like minus 5 greater is smaller than minus 2. Okay, this is the second example we can take to this one. Let's move into the third one. Okay, it's mentioned as a this symbol b. This is we can call as greater than or what equal, right? So we can say like this: a is greater than or equal b. So in this case we have this mention notation. We can write it down like this: a greater than or equal b means a can be a is equal to b. So one condition. So other condition is a greater than b. This one or this one. Okay, it is just like that. Let's move into the final than b, smaller or equal than b. Okay, so example, we don't need to go for the example here, but there are two conditions that can happen here to satisfy this one main inequality expression. It can be a equal to b or a smaller than b. This one or this one can be satisfied if this one acquired. Okay, so now we are coming up to the basic rules of inequalities. So in this theories, I'm going to explain about the main basic rules. What are the basic rules that we learn in when we were in the grade 6, 7, 10? So it's what are these rules? These are addition, subtraction, multiplication and division, right? Addition, subtraction, multiplication and division. So in the inequality also we are discussing these four type of basic rules. Okay, so as per the first one, we can take a greater than b. So we are mainly looking at the addition part at the beginning. So that's a k value. K is a real number. So that's means we can denote it look like this. It's a real number, right? So in that case if we added this particular k value to both sides, the thing is the expression, the direction of this inequity expression will not change if we added this k value to both sides. Okay, and this is the thing we should know. Example, we can say we have a inequity expression like this, 2 greater than 1, and if we added some particular -1 to both sides, so here we will get 1 greater than 0. So we have already know this one is correct. Okay, so this is the basic rule number 1. Let's move into the other second one. In this case, it's the same as the previous one. If we have a particular expression just like this, and there's some constant value k, which is a real number. So if we subtract this k value from the both side, if it's a real number, if we subtract both sides of the inequity from this k value, the direction of this inequity expression will not change. So this is the second rule. So for example, we will have minus pi greater than minus 10. So let's subtract some particular minus 1 case, in this case k is equal to 1, and minus 10 minus 1. So here we will get minus 6 greater than minus 11. Okay, it's correct, right? So this is the explanation for the subtraction. This is subtraction, right? Subtraction. The third concept, we have expression like this again. So but in this case we have a k is also a real number, but in this case k is greater than 0. That means k is taken the positive values, just like 1, 2, 3, just like this. Okay, it can be factors also. So in this case, if we multiply the both sides by this k value, if this k value is also positive, inequity direction of the inequity will not change if this k value is positive. And example, we have 2 greater than 1. So if we multiply both sides by positive value, example pi, so here we will get 10, then pi. It's also correct, right? So, and there's another condition, k can be take the negative value also. That means minus 1, minus 2, minus 4, like that, to infinity numbers of numericals. So here we have a greater than b, and if we multiply both sides by k, and k is also negative, the direction of this inequity will change the other way around. So you should know that. Example, we can take pi greater than minus pi. Okay, so if we multiply both sides by minus 2, we should need to change this inequity direction. Here we will get minus pi multiplied by minus 2. So we'll get here minus 10 smaller than 10. You should know this one is correct, right? So we have finished Okay, you should have expression like this, and k is also same as a real number. In this case, k is positive in the best case. If we divide both sides by this k value, and k is also positive, so the direction of this expression will not change. Okay, so as for the example, we can take 2 greater than 1. If you divide the both side by 1, it's a positive value. It's like it's for the k, right? And here also divide by 1. If we know that this one is a positive, so the direction will not change to other way around. Here 2 greater than 1. We know that is correct. So there's another possibility here. This k value could be a negative also. Okay, so that means k take -1, -2 like that. So in this case, you know a greater than b, right? If we divide the both sides by k value, and we know that k is also negative, so in that case the direction of the inequality will change to other way around. So as for example, -10 greater than -20, right? So if we divide the both side by -10, we know that the k value here is a negative. So the what will happen? The direction of this inequality expression will change to other way around. Here we will have 20 -20 divided by -10. So here we will get here 1 smaller than 2. It's correct, right? So we have, in this case, we have some basic example. The first one is given as 3x plus 1 greater than x plus 7. So here we need to find out the x values that satisfy this particular inequality expression. So in order to do that, we first need to point out this x to left or right hand side. So we can do that by subtracting both sides by x. So here I will write down all this step because this is a first example, right? X plus 1 greater than x plus 7 minus x. X to x will be cancelled out here. Here we will get 2x plus 1 greater than 7. Again, we need to point out the x terms only one side. So in order to do that, we can subtract both sides by -1. Here 2x plus 1 minus 1 greater than 7 minus 1 here. So we will get 2x greater than 6. Again, we need to subject out the only x terms. In order to do that, we need to divide both sides by 2. But we know that 2 is a positive value, therefore direction will not change. Here 2x divided by 2 greater than 6 by 2. Here we will get x greater than 3. So we can draw out here x. This is 3, right? So it look like this. So this is the answer for the first example. Here of t, here should be x, right? So that's why I marked out here. So next move to the next example. So if you have any question regarding this section, please drop a comment below. Okay, so I can reply back to your problem. Let's move to the question number 2. Here we will have 2 minus 3z smaller or equal to 6 plus z. So again, it's just like a previous example, we need to point out the z terms in one side. We can do that by addition reset term to both sides. So therefore 2 minus reset plus reset less than or equal to 6 plus z plus reset, right? So reset terms will be cancelled out here. We will have 2 less than or equal to 6 plus 4z. So again we need to only isolate the z terms on one side. So due to that we have to subtract both sides by 6. Okay, here 2 minus 6 less than or equal to 6 minus 6 plus 4z. Therefore 6 terms will be cancelled out here. So we will get 4z greater than or equal to minus 4. Okay, so here again we need to point out only z components. So we can do that by dividing both sides by 4, and 4 is a positive value, therefore inequality reduction won't change. So we need to divide both sides by 4 and we'll get z greater than minus 1. So we can draw it out. We can put it like this. Here is z, here minus 1, but z greater than or equal marks. Due to that we need to mark out here. So that implies this minus 1 can be entered into the equation. So this look like this. Z greater than or equal to minus 1. It can be greater than to minus 1 or it can be equal to minus 1. Okay, let's see that whether this answer is correct or wrong. Okay, you can see here answer is correct. So we have already finished all these given examples. Okay, I think you would understand everything, but don't worry, this is your first time. I hope you learn in this particular lesson, so don't worry about that.